Welcome back to the Basic Beginners FreeCAD course. I will help you understand the process of modeling real-world objects into FreeCAD, along with practical exercises to help you on the way. In the previous exercise, we gained an understanding of how to tackle more complex subjects. We used the example of a mug, first simplifying and breaking it down into separate components to identify the necessary CAD operations required to build it. It was clear the mug consisted of two main components. Fortunately, each could be created with just one operation. However, for something more complex, such as this lighthousing, where do we start? The interesting thing about this subject is if the top was a dome rather than an oval one, we could handle most of the subject with a single revolve and a few extrusions. However, if a client requested a change to an oval dome, we would need to remodel from scratch, starting from a different plane. By looking at the silhouette from the subject from the top view and one of the sides, we see that some simplification is needed first before we begin identifying the operations required to build it. But even after simplification and before inspecting the other side, we can see that a different approach is necessary. We can't define the shape with a simple revolve, because viewing from the top, we can see that the cross sections aren't circular. We have an ellipse. But there is another approach if we tackle it from the top plane rather than the side, as we did with the revolve. By inspecting the subject, we can see that it's built on different levels or on the same plane. We can think of this as layers. We can work from the bottom to the top, identify the operations needed on each of these layers. Basically, we're splitting it into components again. If the subject can be physically taken apart in the real world, it can be more straightforward to model. For example, consider a pair of scissors. We wouldn't model it as a single object. The screw, which is known as a fastener, can be removed, leaving two sides. These two sides are made up of the blade and the handle. Additionally, the handles can be detached from the blades, resulting in a number of separate parts. The subject is therefore known as an assembly. From there, we can identify the unique parts. In this case, we only have three: one side of the handle and blade, along with a fastener. These are then individually modeled and later reassembled in a special kind of workbench called an assembly workbench. An assembly could consist of sub-assemblies. In the case of our scissors, one side could be built by combining the blade with the front and back of the handle. This is then assembled and saved off as a sub-assembly. Now we just have the sub-assembly and the fastener. When we come to reassembling, we take that sub-assembly and duplicate it and bring them both together with the fastener to create our finished assembly. Each part of this assembly will be modeled separately. Additionally, each part would undergo a repeat process of simplification. For instance, the blade can be simplified as a basic extrusion for the steel, and then an edge is added using a chamfer. These two elements are features of the blade. The part design is a feature-based modeling approach. It can be helpful to consider how the object was created in the real world. In the case of the blade, the steel is first shaped and then later sharpened. We replicate this process in CAD in a similar manner. The process of simplification and breaking down the model into its component parts can be expressed as a flowchart. We first examine the subject. We assess if the subject is assembly and it can be taken apart or disassembled. If that's the case, we disassemble it into parts, and then we take each one of those parts and go through the same process, asking ourselves, is it an assembly and can it be broken down again? This creates our sub-assemblies. If the answer is no, then the object is possibly a composite, where it can be separated into self-contained sections. Remember our mug, where it was a vessel and a handle. If they can be separated, then they are, and then we can take each one of those and put them through the same process, and gives us an idea of what operations we need to create the end model. We combine those operations with their additive or subtractive, and if we've got an assembly, we do the same. We combine them together into sub-assemblies. We will tackle assemblies and introduce the assembly workbench in later lessons. But for now, let's tackle that lighthousing. Through that exercise, we'll be introducing another operation in CAD, and that's primitives. This adds another decision flow to our modeling flowchart. So I hope you enjoyed this lesson, and I look forward to seeing you in the next exercise. If you like what you see and you want to donate to the channel, then you can do so via Ko-Fi or Coffee at ko-fi.com/MANG0 or via PayPal at paypal.com/paypalme/DarrenBEstone. I also run a Patreon where you can get early access and additional content, and that's at patreon.com/MangoJellySolutions. Links can be found in the channel header, on the About page, or in the descriptions of these videos. I thank everybody that's donated so far. It really helps to keep the lights on so I can produce more content and also expand the channel. Thank you for liking, commenting and subscribing to these videos, and I hope to see you again in the next one.